Hey there, YouTube. I've got a project for you today. This project's about a rocket mass heater. Some of you may know I've had some other videos where I've played with a rocket mass heater. Not for mass heating though, for aerospace heating. I was planning to use one for a tent. Had lots of trouble building the mass heater to get it to run reliably with the wood and everything. So I've been doing a lot more research since and decided to try out building one with air-crete. Air-crete is a mixture of concrete and foam. Concrete not being concrete but just the plaster part. So no gravel, no cement, no gravel, no sand. To do that, so what I wanted to do with this whole project was I wanted to get some empirical data on how the rocket stove design affects the performance. So the way people have done it that I've seen on YouTube was basically taking images, video, and seeing how it performed. What I want to do is try to get some data through measuring, say, temperature at different locations, and same amount of mass of wood in each test run, changing the design. The design I want to go with for this one, because I want to have it self-feeding to a certain extent, I'm going to go with a large hopper box and have that all built out of air-crete for the tapered part, and then there'll be a vertical section which would be just an empty box. The lid would be opening, 100% sealed, and then an air vent on the front of it, so air comes in and goes through to the fire tube. Air-crete is concrete, so I'll be building it in pieces and then cutting it and fitting it together and gluing them back together with a little bit of plaster. I'm going to build the cylinder, the riser tube out of air-crete as well. I'll probably take a 4-inch tin to make the inside, and outside I'll make a 6-inch tin, so it'll have 4-inch diameter. So that'll be around 15 square inches. So the inlet line will be probably 4x4 square. And the feed tube, I've seen a few designs where they use a much larger feed area than the burn area, or at least the the horizontal fire part. So what I'm thinking is larger. I'll do two designs on the feed section. One will be tapered two sides and the back down to an area that's a little larger than the feed area opening, and that should be the burn egg chamber, is basically the bottom of the feed area. The second one I'm going to make it deeper, so it's just the two sides are tapered and the back and the front are straight. And then the idea here would be, with smaller logs, putting them in horizontally and stacking it full. So yeah, we'll see that. The second aspect about testing a rocket heater would be the temperature reached. So people have tried to work on turbine or vortexes. I think that there's potential there. So what I'm going to do is build one vertical fire tube and then cut the whole offset and hook the horizontal chamber up to that. Test run that. I'm going to measure the temperature at the discharge plate. So what I'm going to do is I'm going to take a piece of 1/4-inch steel on top of the discharge and set it up about 1 inch high so it's got the right ratio. Then I'm going to put a temperature probe onto that plate. Then I'm going to seal the whole thing in with just a tin garbage can for temporary, just for testing purposes. So it's in an actual rocket stove design. But I'll leave all that the same, and this way I can take the can off, make changes, put the can back on, and then I'll at the bottom of the can at the back I'll have an exhaust riser. So I want to also test the one thing is you've got the offset of the inlet of the fire tube into the vertical fire chamber there, or whatever it's called. The next thing I want to also test is preheating the air coming in. So I was thinking about this, thinking about the preheated air. Can either run tubes through the heating chamber, so which is where the exhaust gases are turning and coming out over the fire chamber and going down towards the exhaust. So you can run tubes through there, heat that air, use that as the inlet air to the firebox. But I think what I'm going to do for the testing purposes, I'll just take a heat gun, and at the firebox where the inlet air is, I'm just going to build a little temporary box and then use a heat gun to heat the air up in there. And then as it's running, it's pulling in hot air from the heat gun, instead of going through the work of actually building the tubes. So what I'm going to do is I've got it, been getting into Arduinos lately, and I've got some temperature elements on order. I'm going to hook up a couple temperature elements. I might get a pressure sensor and try to measure the atmospheric pressure inside the fire chamber. We'll see if I can build something that's going to be reliable and not melt down the temperature element or the pressure element. And then I'm going to set up a data capture through Excel, and basically every 5 seconds I'll capture the temperature element. I'll do one at the 1/4-inch plate on the other side of the plate, so measuring the temperature the top of the plate gets to. And then I'll probably put another one right in the bottom where the fire is, in the horizontal section. Put another element in there and measure that temperature as well. So I'll track those every 5 seconds. I'll build a chart. We can see then the different styles of feed box design or vertical cylinder type, or I can even play with the spacing between the main plate on top and the riser tube, the fire tube. So there's all kinds of variables I can play with. Of course, the goal is to play with one variable at a time to see independently how they respond. And yeah, so the first thing I'm going to do is get some video going, recording, building, pouring the concrete for the different parts for the feed section, the burn chamber, and the vertical fire riser. So yeah, I think it was the Honeydew Carpenter. He built a foam machine out of PVC. I've got some parts. I'm going to get busy, and I'll just show you guys some snippets as we go along. Hope you guys enjoy it. Thanks.